Imagine owning the factory behind artificial intelligence. Inside your building, thousands of powerful computer chips work day and night. They help companies train chatbots, create images, generate videos, discover medicines, and process more information than any normal computer could handle. Customers may pay thousands of dollars every hour to use your machines. A single long-term contract could be worth millions. It sounds like the perfect business for the AI age. Build a giant warehouse, fill it with computers, connect it to the internet, and let the machines make money while you sleep. But that picture leaves out almost everything. Before earning your first dollar, you may need to buy land, secure enough electricity for a small town, build your own electrical substation, install industrial cooling, hire engineers, protect the building from fires and cyber attacks, and spend tens of millions on computers that could become outdated within only a few years. So, what does it really cost to own an AI data center? How does the owner make money? And could this digital goldmine become one of the most expensive mistakes an investor could ever make? First, an AI data center is not simply a room full of normal computers. A traditional data center may store websites, emails, business files, and cloud applications. An AI facility is built for much heavier work. It uses large groups of GPUs, or graphics processing units, to train and operate artificial intelligence models. These chips must work together at high speed, moving huge amounts of data between servers. That requires powerful networking, large storage systems, specialist software, and reliable internet. Every part consumes electricity. One NVIDIA DGX B200 system contains 8 powerful GPUs and can use about 14.3 kilowatts at maximum power. That is only one system. A large AI facility may contain hundreds or thousands of similar machines. Once networking, cooling, lighting, batteries, and electrical losses are added, the total power demand becomes enormous. This is why the first question is not, where can I find cheap land? The first question is, where can I get enough power? You could buy perfect land and find customers, but if the utility cannot deliver enough electricity, the project is useless. Power connections can take years. Developers may need new transformers, transmission lines, generators, and a private electrical substation. In some markets, companies are reserving electricity before they even finish designing the building. Power availability is now one of the biggest limits on data center growth. Then comes construction. A serious data center needs security, fire protection, backup generators, batteries, cooling, fiber, and multiple electrical paths. It must keep operating when one system fails. Industry construction benchmarks show that traditional data centers can cost roughly $10 to $13 per watt in several major American markets. At that level, a 1 megawatt facility may require around $10 to $13 million for core construction. A 10 megawatt project can move above $100 million. A 100 megawatt campus can cross $1 billion before the owner even buys the AI computers. Liquid-cooled AI facilities can add another 7 to 10% compared with similar air-cooled projects. And those numbers may still exclude land, financing, major utility work, fiber routes, professional fees, and the actual servers. The computers can cost even more than the building. A 1 megawatt AI operation could theoretically support around 70 DGX B200 systems near maximum load, or roughly 560 GPUs. The computer equipment alone could cost tens of millions of dollars. Now the owner faces another problem. Buildings can remain useful for decades. AI chips cannot. A new generation of hardware may offer more speed, more memory, and lower electricity costs. Customers naturally want the newest and most efficient machines. So, while the owner is still paying for today's GPUs, a competitor may open a facility using better ones. That is the dangerous clock inside this business. Every unused hour is not only lost income, it is lost income from an asset that becomes older every day. But expensive chips create another challenge: heat. Almost all the electricity entering a computer eventually becomes heat. If the owner cannot remove that heat, the machines slow down, shut off, or suffer damage. Traditional facilities use large air conditioning systems, but modern AI racks are far denser. Some use direct-to-chip liquid cooling, requiring pumps, pipes, heat exchangers, leak detection, and trained technicians. A cooling failure is not a small inconvenience. It can stop customer work, break service agreements, and place millions of dollars of equipment at risk. Then there is backup power. Batteries must respond instantly when the grid fails, followed by generators during longer outages. These systems may sit unused most of the year, but the business cannot safely operate without them. So how does the owner make money? There are several models. The first is colocation. The owner provides the building, electricity, cooling, security, and internet connections. Customers bring their own servers and pay monthly for space and power capacity. In leading North American markets, smaller wholesale requirements have recently been advertised near $200 per kilowatt each month, although real contracts vary by location, size, power price, and lease terms. At that simple rate, one fully rented megawatt could represent roughly $2.4 million in annual rent before expenses. The second model is GPU cloud rental. The owner buys the computers and rents GPUs by the hour, month, or long-term contract. Revenue can be higher, but so is the risk. Imagine a facility with 560 GPUs. If each GPU rents for an average of $7 per hour and the machines are used 70% of the time, gross annual revenue could reach about $24 million. That sounds amazing, but at 40% use, revenue falls to around $14 million. At 20%, it falls below $7 million. The building still needs electricity, employees still need salaries, loans still need payments, and the hardware continues losing value. Utilization is therefore one of the most important numbers in the entire business. The third model is a build-to-suit facility. The developer finds a large customer first, then builds the center specifically for that customer. The company may sign a lease lasting 10, 15, or even 20 years. This reduces the risk of an empty center, but it makes the owner dependent on one powerful customer. If that customer leaves, the specialized facility may be difficult to lease again. The fourth model is private ownership. A technology company builds for its own AI products, gaining control of computing capacity, sensitive data, and long-term cloud costs. If you enjoy documentaries that reveal the hidden business behind modern technology, subscribe now, because the next part is where this dream can turn into a financial disaster. The monthly expenses never stop. The largest bill is usually electricity. A 1 megawatt IT load running continuously uses 8.76 million kilowatt hours per year. Cooling and other facility systems raise that total even further. At an average electricity price of 10 cents per kilowatt hour, total yearly power spending can easily move beyond $1 million for a facility of this size. Now imagine a 100 megawatt campus. The electricity bill can reach tens or even hundreds of millions of dollars, depending on the contract, efficiency, and actual use. This demand is becoming large enough to affect entire power systems. The United States Department of Energy reported that data centers used around 4.4% of American electricity in 2023 and could reach roughly 6.7 to 12% by 2028. The International Energy Agency expects global data center electricity use to more than double, to around 945 terawatt hours by 2030, with AI as the biggest driver of that growth. The owner must also pay engineers, security, software teams, electricians, cooling technicians, insurance, taxes, internet providers, repairs, and customer support. The center runs 24 hours a day, requiring multiple shifts. Then come the risks. Nobody puts in the promotional video. A transformer may fail. Construction may be delayed. Cooling may leak. Cyber attacks may frighten customers. Electricity prices may rise. Communities may oppose noise, water use, or pressure on the grid. And the biggest danger may be simple. The owner builds too much capacity before finding enough customers. A half-empty AI data center is not passive income. It is an expensive machine burning electricity while waiting for someone to rent it. Still, the opportunity is real. Demand for AI computing continues to grow. Companies are fighting for access to power and data center capacity. North American vacancy has remained extremely tight, and developers are pre-leasing buildings long before construction is complete. The successful owners may not create famous chatbots. Their names may never appear on the products used by millions of people, but they control the land, power, cooling, and computing infrastructure behind those products. So, can an ordinary person own an AI data center? Technically, yes, but the realistic starting point is not a billion-dollar campus. A smaller entrepreneur could lease racks, buy a limited number of GPUs, and expand only after proving demand. To build a complete facility, the owner needs 4 things at the same time: capital, electricity, hardware, and customers. Missing any one of them can destroy the project. Without capital, construction stops. Without electricity, the building is useless. Without modern hardware, customers go elsewhere. And without customers, the machines become very expensive furniture. An AI data center can generate recurring revenue, secure long contracts, and serve companies around the world. But it is not simply a technology business. It is a real estate development, a power project, a cooling plant, a construction operation, a cybersecurity company, and a cloud service, all operating under one roof. The computers inside may create artificial intelligence, but building a profitable business around them requires very real intelligence.